Hi everyone, this is Math 125 Test 1 review for the Intersession course. It's a little bit longer. I won't work every single problem, but I'll try to work every type of problem. So let's go ahead and get started. First, convert the given radical expression to rational exponent notation. All right, we have 2x plus 7. Okay, converting it to where it's written in terms of something to a power. This you've got your 2x plus 7. It's all in parentheses. You're going to raise the whole thing to the 3/11. Very important that you put it in parentheses. This is all we wanted. We just need to be able to write it back and forth in different forms. So the second one, convert the given expression to radical notation. This is just going backwards. It's given to you as a power. Now we want to write this as an actual root. So what we have is the 3x. Sorry, I'm having problems with my pencil. 3x plus 7, okay, that's what we have. The denominator of the power, which is 7, that's the what root you have. Be very careful. If you just put this as squared, this is incorrect, because the way I've written it here, it's just 7 squared, but we want the whole thing to be squared. Okay, so the parenthesis is very important. Okay, doesn't require any scratch work. It's just simply, can you write them both ways? All right. Let's move up here to rationalizing the denominator. Okay, so we have rationalize the denominator, and we have problems that say rationalize the numerator. They are worked the same way. Of course, rationalize the denominator means we want to take the denominator, right here, the 2 minus square root of 3, and we want to write it to where there's no square root in the denominator. That's what rationalizing means. So what you do is we're going to use what we call the conjugate. Okay, so we have 2 minus square root of 3 of x. Take the one you're trying to rationalize, the one that's got the square root in it. We're going to use the conjugate, which is simply, sorry, I'm having problems with my Apple pencil. I might have to take a break and try to fix it. Okay, do you see that? 2 plus square root of 3? Okay, so it's the same thing except different sign. And whatever I multiply the denominator by, I have to multiply the top by the same thing. This is okay because, look, we're basically multiplying our original problem by the number 1. Right? When you have two values over each other, that's just the number 1, which, of course, when you multiply anything by 1, remember that just reproduces the same thing that we have. So we haven't changed the ratio at all. Okay, by doing this, for the numerator, don't multiply this out. I'm going to rewrite it. 3 times 2 plus square root of 3. Okay. Keep that the same. On the bottom, this is where you want to multiply it out. As I've explained before in the videos, this is the difference of two squares. So when you FOIL this out, you're going to say, I'll change colors. We have 2 times 2. Right, is 4. The outer, 2 times square root of 3 is plus 2 square root of 3. The inner, right here, 2 times negative square root of 3 is negative 2 square root of 3. And finally, the last one, negative square root of 3 times square root of 3 is negative square root of 9. Okay? All right, so let's see what we have from here. I'll go back to black. On the top, once again, don't multiply that out. You can, but a lot of times you'll be left with something in the denominator that can cancel with either that 3 or whatever number would be there. So I would keep it this way. On the bottom, let's simplify it. We have 4. Right here, the 2 minus 2 square root of 3, those cancel to give you 0, and it should do that every time. And then we have minus square root of 9, which is minus 3. All right, see, no more square roots. They disappear. So we're left with 3 numerator. And then 4 minus 3 is 1. Okay, this one happened to have 1 as an answer, but a lot of times that denominator will be something other than 1, and you may be able to cancel. Like in some cases, you could have gotten a 6 in the denominator, and then we would cancel the 3 and the 6 to simplify. But for right now, the 1, there's not much else you can do. So your final answer would be this. Some people ask, can I multiply this out and get 6 plus 3 square root of 3? Yes, you can. Either way would be fine. All right, that's rationalize the denominator. Let's look at the next one, rationalize the numerator. It has worked the exact same way, but I wanted to give you another one since this is the numerator. So for this one, zoom in a little bit. Okay, we have square root of x plus 3. This is what we're trying to get rid of. We don't want the square root of x in the numerator. So we use the conjugate, which, like I said, just like last time, you have the exact same values except for the sign. The sign's different. Whatever you multiply the top, you also have to multiply. Sorry, once again, my pencil's messing up on me. All right. So I multiply by the same thing. Okay. So only multiply out the one that you're trying to get rid of. Like in this case, since we're rationalizing the numerator, right? The numerator is what we're going to multiply. So let's see. Okay, we have, I'll do it in blue again. All right. First, square root of x times square root of x is the square root of x squared. The outer, we're doing the FOIL method. Remember, first, outer, inner, last. The 2 outer would be negative 3 times the square root of x. All right, the inner would be right here. Positive 3 times square root of x. And then finally, the last, 3 times negative 3, which is negative 9. All right, that's the top. The bottom, like I said, do not multiply this out. Just keep it, because most times you'll be left with something in the numerator that cancels with something in the denominator. Let's multiply the numerator out. First of all, negative 3 right here. There, those cancel to give you 0. Right, they subtract out. So we're left with the square root of x squared is x minus 9. And as you can kind of see on the bottom, we have x minus 9. Okay with that? This is what I was talking about. You're left with the x minus 9 that you can cross out. And you have those cancel. My answer, my final answer would be 1 over. Makes sense? So when you simplify, you want to cross out the x minus 9. I've seen people in the past cancel them, but forget to put the 1 in the numerator, and that's very important. All right, so there's an example of rationalize the numerator and rationalizing the denominator. Hope that helps. Now let's move on to factoring the polynomial. Factor the polynomial completely. We're just practicing factoring. This is a difference of 2 squares. If you notice, the 9, remember, is 3 squared. And then 25 is 5 squared. So if you notice, everything is a bunch of squareds. So look at the 3 and the x. We can rewrite that since they're both squared. We can rewrite it as 3x all squared. I just combined those. Minus 5 squared. Okay, so a difference, which means subtraction, is difference right here. The subtraction. You have 3x squared and 5x squared. If you have a difference of 2 squares, very simply, it factors into 2 parentheses. 3x makes up the first term of each one. 5 is the second term. One of the parentheses is plus, one is negative. Very simple. We wanted you to go through this because throughout the rest of the course, we factor polynomials a good bit, and a lot of times you'll have the difference of 2 squares. So we wanted you to be able to recognize that. All right? Okay, there's one problem. Let's go to the next. Solve the equation. And be prepared going back. We're not working as many since it's a review for time. But being able to factor polynomials is kind of important for this test. Solve the equation. Okay, this is a basic linear equation. So first things first, we want to get rid of our parentheses. I'm going to rewrite it, if that's okay, just a little bit bigger for me. It's kind of small. So what we want to do is we want to get rid of our parentheses first, right? So we can take our 3 and distribute it through, right? So that would be 3 times 3. And here we can distribute, right, our negative 2 through, so 2y. Okay, combine anything that's you can on each side. Let's see, I don't want to run out of room. I didn't leave myself a lot of room. So we have 3 plus 6, so we'll get 9 minus 2y. Okay, so from here we want to combine our y's, or in this case the y, or whatever the variable is, to one side. I'm going to bring negative 2y to the left side, so I can, I'll do it in red. Let's see. We have plus 2y. And then we want to take the 9 to the other side. We'll subtract 9. Let's see what we have. We have 9y plus 2y is 11y. This is 0. We get 0 and 0. You good with that? So we have 11y equals 0. Final step, divide out by 11y. You get y equals 0 over 11. As you know, with fractions, 0 over anything other than 0 is just 0. So my answer is 0. Be prepared that you could possibly get no solution or all real numbers, and a lot of times you'll get some regular number other than the number 0. So this one just happened to be, this is the one that I pulled up when I pulled up the review. I got 0. Okay, let's do solve the linear inequality. Here we have, you work it the same way. The only thing that's different is the way you write your answer and when you divide or multiply by a negative. So let's start out. Let's take our 2x. Distribute through, we have 2x. 2. Hopefully that's a little clearer for you. Combining, we have 2x right here, right? 2x minus 4x is negative 2x minus 2. All right. So here we go. We want to bring our x's all to one side. So I'm going to subtract x from both sides. Right? That gives me negative 3x, right? And that's 0. And then I'm going to add 2 to the other side. Good with that. So we have 0. Over here, that would be what? Plus 21. So we have, let's go back to black, we have negative 3x equal to 21. Okay, you work this just like a regular equation until you get to this part. Notice our last step, we've got to divide out because it's a negative 3. We've got to divide both sides by negative. When you divide by a negative number, when you're dealing with inequalities, don't forget, remember, you have to change that sign, the direction. Just don't forget that. I'm running out of room, but that gives you, everybody good with that? Don't forget to change the direction. You don't change, if that had been a positive 3, you don't have to change it. Okay, so my answer is x is less than or equal to negative 7. All right, so I wish we could write this as our answer, but all math textbooks always ask you to write the answer in interval notation. So this one with interval notation, it may help for you to draw it out. You don't have to, but I'm going to draw it on a number line. X in this case is everything less than, right, or equal to. So that means it includes negative 7. Right, so my answer is the shaded area in the black. So from left to right, interval notation, since this is negative infinity, it would go negative infinity, negative 7, bracket. So remember, the infinities, negative or positive, is always a parenthesis. But at the -7, if you have less than or equal to, then you have a closed dot. I'll put it in red. The fact that it was equal to right there means you do the closed dot and you do the bracket. All right. If it was not equal to, then it would have been an open dot and a parenthesis. Okay? But that's how you write your answer. That is the inequality. Let's see, I think we have another one. Yeah, here's a 3-part one here. 3-part linear inequality. Let's do this one. Let's see. We have 11. Let me look. So we have 11. Notice there's 2 inequality signs. Basically, you treat this like a regular equation, kind of like it has 3 sides to it. So whatever you do to one side, the middle, you need to do to both sides, or all 3 parts. Our goal here is we want to get x by itself in the middle. So let's look at this 3x plus 1. First thing, we want to get rid of the 2. We can do that by multiplying both sides. I should say all sides by 2. So I'm going to get rid of that fraction. So let's multiply that by 2 and then each side by 2. Since it's positive 2, we don't need to change the direction of the signs. By doing that, notice these 2's cross out. It doesn't affect the 3x plus 1. The 2's cross out, but you no longer have a denominator, which is great. No more fractions. So we have 2 times 11, 22. The 2's canceled, right? Remember, those canceled. So we're left with 3x plus 1. And then here we have 17 times 2 is 34. All right? Okay, so we're still trying to get x by itself in the middle. So let's get rid of that 1. We can subtract 1 from all 3 sides. And that leaves us 21. Make sure I get that right. And what's that, 33? Once again, you're subtracting. The only time you change the direction of the signs is when you're multiplying or dividing. And we haven't done that yet. So here we're almost to our last step. We have 3x, but we want x. So let's get rid of the 3. And since it's multiplied by x, we want to divide it out. Divide by 3. Positive 3, which means we don't need to change the direction. We get 7. All right, this is our answer. But now I'm circling it. I'm putting a square around it, a box. But that's not what you put as your answer. You have to write it in interval notation. All right, so I'm going to draw it out just to help you see. This is basically saying we have 7 and 11. You do it on your number line. And x is anything in between, right there. We just need to get the boundary points right. So at 7, notice at 7, I'm going to do it in red. That's okay, so you can see the difference. Look, 7 we have greater than or equal to, so that means we include 7. That's part. But 11 is strictly less than, not equal to, which means we do not need to include 11. So I put an open dot. So my answer, that means we get 7 to 11. Notice, when it's equal to 7, you do a bracket. When it's not equal to 11, you do a parentheses. This is the way you need to write your answer. This is called interval notation. Okay, so those are 2 of the inequalities. For this test, we're just dealing with basic linear inequalities. We deal with larger inequalities later, I think in the next test. All right, solve the following equation by factoring. Now we're getting to the all of the equations, okay, the quadratic equations. We've done linear equations, which is just x to the first power. Now we're getting to equations that have maybe x, or in this case, a v squared. So solve by factoring. This is the one we like the best. If we can factor, that's exactly what we want to do. So the rules for factoring. First thing first, we want to set this equal to 0. So since it's equal to 20, we want to bring 20 over to the other side. So we'll subtract it to the left side of the equation, and that leaves 0 on the right side, which is what we wanted. If they tell us we can factor, we should be able to factor this. It's just factoring quadratics. So let's see, we have v times v and 20. I'm going to do 10 times 2 because I know 10 minus 2 is 8. So let's get it all right. We need negative 8, so let's do negative 10 plus 2. So it factors. Once you have it factored, just remember, take each factor, set it equal to 0, and solve. You'll get 2 answers. This one, add your 10 to the other side, v equals 10. All right, and then this one, you'll subtract 2 to the other side, v equals negative 2. Makes sense? So we get 2 answers. When you're listing this on your test, you basically can just say 10 comma negative 2 and list them with a comma. It doesn't matter what order. That's basically what you do. Okay, so that was a basic factoring. It's nice when we can just simply factor, but of course we're not always able to do that. So let's move on to the next. Here's a factoring. I think I just gave you one more to look because it's just a little bit larger. It's already set equal to 0, so let's see if we can factor this thing. All right. So we have 3x squared. We need 3x, x, and we need, for the last one is 5, so we need 5 times 1. Let's see, we got to get this right. We'll do 5 times 1. We need positive 14. So here we factored that. I think we have that right. So once we get it factored, set each one equal to 0 and solve. Okay, first one, let's add 1 over, divide by 3. We get 1/3, that one. And then the second one, very simply, you can just take 5 to the other side, x equals negative 5. There's my 2 answers, all right? And once again, when you type them into Pearson, you can just separate them by a comma. You don't have to put x equals each time. Okay, that's just another factoring one. Let's move on. Solve by the square root property. Square root property is great, and it's really handy to know how to use it. It's basically saying if we want to use the square root property, we can take the square root of both sides. Well, you don't want to take the square root of this particular problem. If you notice, you have x minus 9 squared. We want to take the square root of that, okay? But you don't want to do it till it's by itself. That makes sense? So before we do that, we want to move that 1, clear that to the other side, right there. So we would have to add it over, right? And there we go. So now you have it by itself. So very simply, I mean, you could multiply this out, but you have no idea that it's going to factor. So this really is the easiest way. The square root property simply says, I'll do it in red. Let's see if I can get it to work. You can take the square root of both sides, okay, as long as you remember you have to include positive and negative. So when you actually take the square root to help you solve the problem, the square root property says you have got to remember the plus and the minus. Most everybody usually just puts the positive, right, and they forget to include the negative because you're going to get 2 answers. All right, so that leaves us. The square root square, these just cancel right here and give you x minus 9. And then you have plus and minus. Square root of 1 is 1. Okay? Let's solve for x. So let's clear 9 to the other side. We're going to add 9 to the other side. This way. We get 9 plus or minus 1. So let's work that out. We get 9 plus 1 and 9 minus 1. 2 possible answers. So that minus part is very important. 10 and 8. And that's my answer. So like I said, a lot of people do the square root, but they forget to put that plus and the minus. If you forget the minus, you're not going to get the number 8. You're only going to get one answer instead of 2. That's the square root property. And it's kind of important because we're going to do completing the square. And in completing the square, you have to use the square root property. Okay? Let's move on. Let's see. Solving, here's another square root property. Let's do this one real quick. Solve, use the square root property. Here we have x squared. We have 3. Now the 3 is not squared, right? So before we take the square root of this, we want to clear the 3. We want to clear that out. So the quickest way to do that would be to divide both sides by 3. Since it's an equation, you can do that. Remember, anything you do to one side, you just have to do to the other. So when we divide those out, these 3's cancel. You get x squared equals 5. Okay, x squared equals 5. So now use the square root property. I'll do it in red. Remember what we say. If we're going to take the square root, do it from both sides. Don't forget plus and minus. Okay, the square root of x squared cancels. That's just x. You have plus and minus square root of 5. That is your answer. Okay, Pearson may want you to list it separately like this. Okay, I'm not sure if they'll let you use the plus and minus sign. So if that's the case, you have to list them separately. Okay, but you still get 2 answers. All right, let's keep going. Let's keep going. Solve the equation. Okay, this one's got a cubed in it. Now notice all the other ones that we had x squared, we got 2 answers. X cubed means we could possibly get 3 answers, but we're still going to try to factor first. When all else fails, try to factor first. Then, if it doesn't, then we move to other ways. So this one you actually can factor. Let's see. Let me think real quick. Can we take the 4 out? I think we can. So let's factor out a 4. Sorry, my pen, like I said, is not working that well. We can take a 4 and we can take a c. So when we factor out, we have c squared. Right? And we took a 4 out. You're dividing it out. So if you take a 4 out of 8, you get 2 and a c. And then finally, when we take a 4 out of 140, isn't that 35? I think I'm right. 35. Yeah. All right. So by doing that, equals 0. Right. Okay. This is just helpful because now this little part right here, we can factor it, but it's much easier to factor. So we have 4c. Let's factor this thing into 2 parentheses. C times c, and then 35 we'll do 7 times 5. Right, because 7 minus 5 is 2. I think that's right. So 7 minus 5. You just want to factor it. Now notice, so we factored it, except this time we have 3 factors. So using the same property, you just have to set every single factor equal to 0 and solve. In this case, we'll get 3 possible answers. Okay, 4c equals 0. Look, you can kind of look at it and tell the only way you're going to multiply 4 by anything to get 0 is if c is 0. But if you were to divide it out to solve, you would get 0 over 4, which is 0. So I'm going to circle that. This one, you're going to subtract 7 to the other side. So c equals -7. And lastly, add 5 to the other side. Hope that makes sense. All right, so I did them separately, but once again, like I said before, if you're entering this in on your computer, you can simply enter them separately, divided by commas. Okay, so this is just a factoring. It's c cubed, and we got 3 answers. Just look, that's kind of a little hint to know. Let's keep going. Solve the equation after making the appropriate substitution. All right. This is the directions they'll give you, but we're actually not going to do the substitution. We're only going to look at one kind here. When you have the x to the fourth, there's lots of different ways of working these, but for time's sake, we're only looking at one of these kinds. And the way we can work this one, we can actually factor it, which is nice. We don't have to do substitution. So when you have x to the fourth, we're going to treat it like a regular polynomial, okay? Normally, if we had x squared up here, we would do x times x. But since it's x to the fourth, we're going to do x squared. Right? We treat it like an x squared, but it's x to the fourth. Oh, let's see. And we've got 160. That's kind of large, but we're going to do 16 times 10. It's not too hard because you add those together and you get 26. So that works pretty well. We need negative 26, so that means they both need to be negative. Alrighty, so they factored, which is great. Okay, so the rule for factoring, what do? We set each factor equal to 0, and we solve. So you do it for both of them. Notice we don't have just x minus 10 and x minus 16. We have x squared. So to solve this, we need to use the square root property. Right? I'm bringing negative 16 over to the right. We have x squared and we want x. So what do? I'm going to do the same thing over here. X squared, I'm going to bring negative 10. Okay, and we don't want x squared, so don't put 16 and 10 as your answer. We want x equals. So using the square root property, don't forget positive and negative. This is what gives you your extra answers. All right, so we are left with x equals plus and minus 4. And over here you have plus and minus square root of 10. Not much you can do with that. This is actually 4 answers. Now Pearson is going to make you write these and type these in all separately. So the way you would write your answer would be 4 and negative 4. That makes sense? So you have to list them all separately. Okay, positive and negative. So this is the one that's got the x to the fourth. It's the only one that you'll see, and you can work it this way. So no surprises on that. This is how you'll work it. But just remember, because it had x to the fourth in the problem, you should get 4 answers. All right, let's do completing the square. So very simply, for completing the square, you just got to remember the steps. So to do completing the square, the first thing you're going to do is you're going to clear the constant, which is the negative 2, to the other side. So let's look. This is different than factoring, okay? It's completing the square. Make sense? And notice I left room because the whole act of completing the square is I want to add something to the left side that creates a perfect square. Okay, we didn't have a perfect square. And what is the perfect square? A perfect square is something that, factors into the two of the same factors. Right? So here's an example over here. Let me just show you. If you had had x squared, let's see, plus 6x plus 9. If you were to factor this, you would factor it, just to show you. This is separate. This is not the same problem. 3 times 3. Does that make sense? So when you factor it, it actually is the same factors. It happens to be, which you could rewrite it like that. This is a perfect square, and that's what we're trying to create. That's why we call it complete the square. We want to make the square. So question is, what do we add next to negative 8 to create a perfect square? And the way you do this is you're going to take your negative 8, right here, the number that's by the x. Okay, just take 8. It doesn't matter. The negative doesn't matter. You're going to half it, right? You half it, and you square it. So the 4 is just taken by dividing 8 by 2, half it, and then you square it. That's how you come up with the right answer. So we're actually going to add 16, right? 4 squared. And since you add that to one side, you're going to add it to both sides. So 4 squared over here is the number 16. Does that make sense? So I basically added the same right there. I'll see if it'll write. See, those are the same numbers. And I added them to both sides of the equation, therefore the equation is still balanced. But what I've done on the left side right here is I have created a perfect square. I have completed the square. So x squared minus 8x plus 16 will factor into something squared. So you simply factor it. You take x, you take this sign, which is by the 8, so negative, and then you take the 4, the number that's squared. That's why I like to write it as 4 squared instead of 16. And that's how it factors, x minus 4 squared. On the right side, you have 2 plus 16 is 18. All right, that's completing the square. Okay, you've actually done it. I added the 4 squared to both sides, so I completed the square. Then you turn right back around and you factor it. Once you do this, now you're left is just the square root property. All right, so let's do the square root. We have what? X minus 4 squared. Okay. We can take the square root of both sides. Do not forget plus and minus. The left side cancels. You have x minus 4 plus and minus square root of 18. Now let's simplify square root of 18. It's a radical, so to simplify it, you can break that down as 9 times 2, and the square root of 9 is 3. So let's do it right over here. X minus 4 equals. There you go. Last step, we want to solve for x, so let's add 4 to the other side. So take 4 over there. You get 4 plus and minus. That's your answer. So I'm going to circle it, but once again, Pearson makes you write them separately, so when you enter this in to your test, you need to write it as 4 plus and 4 minus. 2 different answers. Okay, that is complete the square. I hope that makes sense. If I move too fast, you certainly can rewind it and go back over it again. Okay, solve the radical equation. We're moving on to the next section, talked about solving equations that have the square root in it. So to solve this equation, I'm going to rewrite it just a little bit larger, a little bit easier for me to write. Okay, we want to get rid of that square root sign. Okay, so very similarly to the, taking the square root of both sides, if you have a square root, you can square both sides. Okay? Just as long as you do it to both sides of the equation. So I can actually square that, because when you square the square root, they cancel. But you have to square both sides. Okay? So what do we have? On the left side, these canceled, and you're left with 9 minus 9x. This is so great because it's a quick way to get 9 minus 9x out from underneath that square root sign. So you have that. Now on the right side, be really, really careful. X plus 9 squared is not x squared plus 9 squared. It is x plus 9 times x plus 9. Makes sense? This is different than just squaring the x and squaring the 9. When you do this, you have to FOIL it out. Right? Remember, we have first, I'm doing blue, first, outer, inner, last. So you have to multiply 4 things. So let's see what we get. First is x squared, then we have x times 9. X. The inner. There we go. So we have basically 9 plus 9 right here. You get okay, see, notice that's different than if from the very beginning you had just squared the x and squared the 9. You would have just gotten, you just wouldn't have gotten the 18x. It messes up your whole answer, so please watch for that. So once you've done this, you are left now just with a quadratic equation. And the way we're going to solve it, like we always solve quadratic equations, bring everything to one side, set it equal to 0, and hope that it factors. And I'll just tell you, it should factor for these problems. So let's bring everything to the right. So by doing that, I'll change it to red just to separate it. I'm going to get rid of 9, so I'm going to subtract 9 to both sides. And I'm going to add 9x. You okay with that? That leaves us a 0 right on the left, which is what we want. Okay, 18 plus 9 is 27x. Right, and 81 minus 9 is, what's that, 72? I'm right, I'm just doing this in my head. So we're left with a polynomial, a quadratic that we should be able to factor. Now, it's not the easiest, so let me think what this is. It's got to add to give you 27. So what is that? Is that 24? 24 times 3, maybe? What's 24 times 3? 24, doing this in my head, so, oops. 24 times 3, 72. That's good. So I'm going to split this into 24 times 3, because if you add those, you get 27. All right, so it did factor. Like I said, these problems, any of this problem that you get, you should be able to factor. So if you can't factor it, go back and check and make sure you didn't make a mistake. When you solve this, you get 2 possible answers. Right? Set each one equal to 0, you get negative 24 there and negative 3. You get 2 possible answers. Negative 24, negative 3. Okay, one thing to know about this is for this problem that has, if you go back to the top, right, it has the square root in the original problem, you must check your answer. Check. You've got to check it. Because when we end up squaring both sides in that first step, you know, right up here, when we squared both sides, what we did is, since we deal with negatives, you know, sometimes when you square a negative, it gives a positive. So just by doing that, we open up the door that we could get a false positive for our answer. So you want to check and make sure. So let's look and see what we have. If I can erase. So to check, all you do, very simply, we'll go up here. Take the original problem, right? Original problem. I'm going to recopy it, but you certainly don't have to. Okay, so to check, plug your, let's check negative 24 first. You're going to plug it in for x, right? You're going to plug it in times negative 24. And you just want to see if this is true. Oh, goodness, it's some big numbers. So let's see, 9, and then 9 times 24. 36, 8. 216, I think I'm right. I'm doing that in my head. But that gives you the square root. 9 plus 216 is 225, right? And then over here, negative 24 plus 9 is negative 15. Makes sense? The square root of 225 is positive 15. And then my right side, I got negative 15. This does not work. Does that make sense? It doesn't come out to be equal. So that means negative 24 is not my answer. Okay, so that's kind of what you're looking for when you check. Now let's do, really quickly, let's do the 3. I'm running out of room. So we'll do it over here real quick. Let's check that. We're going to check negative 3 right here. Okay, so same thing. Plug it into the original problem. Negative 3 equals, okay, what's that? 9 plus 27? 36, which is 6. And over here, negative 3 plus 9 is 6. Okay with that? So both sides are equal, which is what you wanted, which confirms that negative 3 is my answer. Okay, so please, please, please do not forget to check your answer. Usually when we work this test, about half of the class forgets to check and they list both answers. Okay, but that's only, that's not correct. So you need to be able to check. There's only one answer that works. Okay, so that's with the radical. All right, let's keep going. Perform the indicated operations. This is just subtracting fractions. You have to get common denominator, so let's look. X plus 3 and x minus 3, the common denominator, they want us in these sections just to be able to know how to get common denominators and to add and subtract fractions. Sorry, I'm trying to be neat. So I'm going to convert each fraction in terms of the same denominator. So my denominator, my common one, I'm just going to multiply the two denominators together and get x plus 3 times x minus 3. So let's convert the first fraction. We have, x minus 1. Okay, so we have x minus 1 over x plus 3. Whatever's new, which in this case is x minus 3, you have to put in the top also. Makes sense? And the same thing for the second. We had x plus 6. But the new value in the denominator is x plus 3, so you gotta put that in there. That's how you convert them. Now these are both two fractions with the same denominator. Only now that we have the same denominator can we combine them into one fraction. So basically, this does require more actual, sorry, I keep dropping my pen. Minus 3. Okay, there's my common denominator. So on my left side, that one minus. Hey, be really careful on this one. That subtraction sign gets a lot of people mixed up and they miss the problem. So be careful with that. What you want to do is, all we're doing is simplifying. We're not solving, it's not an equation. But what we're going to do is we're going to take the first value in the numerator and we're going to multiply these out. Remember, full method. First, outer, inner, last. Okay, so let's do that. We get that one, minus, and we're going to do the same thing, and I'm going to keep it separated with parentheses. Very important since you're subtracting. Oops, sorry. So fooling this one, x times x, 3, inner, 6x, and last. Okay with that? All over. You don't have to do anything with the denominator. So here we are. We have it multiplied out. The final step is we want to combine the numerator and combine as many terms as we can. Okay, but this is why it's really important, that subtraction sign. I kept the parentheses because I'm going to take it in a few steps. So notice for the first parenthesis, I can combine the two middle ones. So I get x squared there, right? And then the second one, I'm going to go ahead and combine 3x and 6x is 9x. Okay, so I wanted you to see it. I know I'm taking lots of extra steps. This is where everybody misses it. They multiply this all out, but then they forget to put these parentheses on the second one. And usually they'll just, this is what we'll have, they'll have this right there. And so you're only subtracting the x squared. But you don't want to do that. Like usually half the class will miss this, so please pay attention. Since you are subtracting the whole thing, right, you have to distribute that negative through. Very, very important. Okay, so let's do that. Oops, I'm going to do it up here. Okay, we have, I don't have a whole lot of room, so I'll try to be neat. X squared. 3. Okay, distribute it through. So minus x squared minus 9x minus 18. Make sense? Distribute it all the way through. This is where people miss it, is right here, because they didn't distribute the negative all the way through. But it's the difference between getting it correct or incorrect. So we have x squared minus x squared. Those cancel. Negative 4 minus 9. And 3 minus 18. Is that minus 15? Okay, this is our final answer. They just want us to have a simplified, sorry this is messy, a simplified fraction. There it is. This is one of the ones that requires probably the most work, the most writing in this, or scratch work. But look, when you turn in your scratch work, I need to see this, okay? I don't want you to jump from the beginning and get the correct answer and don't show me how you got it, okay? All right, let's move to the next. Simplify the rational expression. Okay, very simple. To simplify, you are going to factor the top and factor the bottom and look for things that cross out. So let's factor the numerator. Okay, y times y, and then 40 will do what? 8 times 5? Okay, it's negative 40. We want positive 3, so positive 8 minus 5. There. The bottom, we have 40. Let's do 8 times 5 again. Negative 8 and negative 5 is negative 13. So it did factor. So, okay, this is a two-part question, so pay attention. The first one, they want to know what happens when you simplify it. To simplify it, you can do it in red. You can cancel out common factors, right? So simplified, your answer would be y plus 8 over y minus 8. That's simplified. That's the first part. The second part is they're going to ask you, find the numbers that must be excluded from the domain. Okay? They're kind of looking ahead to something that we're going to do next test. Whenever you deal with fractions, you really have to keep in mind the denominator. Because a fraction can never, ever, ever be equal to 0 in the denominator. It doesn't make sense. Very, very important. You can have 0 in the numerator all you want. You just can't have 0 in the denominator. So they're looking for what needs to be excluded. So simply, from the original problem, you're going to look, sorry, that accidentally went to erase. Apologize. Look right here, that denominator, okay? The values that make the denominator 0 must be excluded, even the one that we crossed out, okay? So if you set that equal to 0, you get 8. And if you set that one equal to 0, you get 5. So there's two values that must be excluded, 8 and 5. You got these numbers strictly from the denominator, right? It had nothing to do with the numerator, the denominator. And the reason is because you don't want the denominator of a fraction to equal 0. Okay, and a lot of people ask, well, but you canceled y minus 5. Well, we simplified it, but the original problem has y minus 5 in it, so you have to include 5 in your answer. Okay? In the past, I've seen people miss this, and what they'll do is they'll simplify it and get, this, x plus 8, x minus 8, and then they'll either just put 8 as an answer, they'll look at the simplified version, or they'll set the top and the bottom equal to 0. That's completely wrong. So please remember the exclusion part right here comes right here from the denominator. Okay? It's a two-part question. Okay, so now simplify the complex fraction. So going through this, I like to use a shortcut method. So if you're watching this, and maybe you watched some of the videos when you were going through this, but I like to use the shortcut method. You don't have to. But to simplify, all we're wanting to do is we're going to turn this fraction, which notice this is fractions inside a larger fraction. To simplify it, we just want you to have a normal fraction where there's just one thing. There's no fractions inside the numerator and denominator. So we want to get rid of these individual fractions. Okay, so the shortcut method is, I'm going to recopy this if that's okay, just so it'll be a little bit bigger for me to work. Now look, you're welcome to take the original problem and combine the numerator into one fraction and the denominator and then divide. But the shortcut method says this. What I'm going to do is I'm going to look at all the fractions. I have 1 over x and 1 over x squared. Find a common denominator, which in this case, the common denominator would be x squared. And what you can do is you can multiply every single term by that one. You have to multiply every single one for it to be, not to throw it off at all. So what you can do is take x squared. Once again, it's from x and x squared. You want to find common. So I'm going to use x squared. All right? I'll multiply each fraction by x squared. And you multiply it in the numerator, right? That's the shortcut method. Okay, because we had x in the bottom and x squared. Okay, by doing that, I'll change it. I'll use my colors. So by doing that, look at the first one. I have 1 times x squared, right? Okay, so the x squared and the x, they cancel. You can cancel out an x, and that leaves 1 more x on the top, but nothing in the denominator. And look at the bottom, you have x squared on the top over x squared. Am I good with that? That equals 1 and 1. Right, so they canceled. So what do we have? We have the first one, we had x in the top over 1, no denominator. And then we have 2x squared. And then we have 1 over 1. These happen to cancel, so we have 1. Makes sense? So in one step, you got rid of the individual fractions, and that's what they're looking for. Now, you do want to check yourself and see, can this be simplified anymore? And the way you would do this is just see, to be simplified, can this be factored? Okay, can it be factored at all? To see if this would help. So let's try it. Well, the top can be factored. You can take out an x. Good with that? The bottom, when you look at it, you don't really think much about it, but look, this is actually a difference of 2 squares, okay? Look at that. The 1, you could write that as 1 squared, and then the 4, you can write that as 2 squared, so you could write that as 2x squared, which means it factors. So let's look at it here. X, I'm going to recopy the numerator. The bottom, it's a difference of 2 squares, so remember how that works. And it's a difference. Right, the 1 is the first. 2x makes up the second. One of them has to be positive and one has to be negative. Okay, by doing that, look, if it doesn't factor, then you're done earlier. But this one actually did. You could cross out those. Your final answer is x over. Okay, now I want to see your work on this. If you got to this first step, right here, okay, you definitely did work with simplifying, and I would give you some credit for that. But taking it a step further gives you full credit because they wanted you to simplify it completely. Okay, so that is the complex rational. I think another one of these. Yeah, one more of these. So I just wanted to give you 2 to look at, just another example of how this works. I'm going to make it bigger so I have room to write. So here it is. I just wanted to give you another example showing the shortcut method. This one we have, 4 fractions inside a larger fraction. So the shortcut method simply says this. Find a common denominator among all 4 fractions. So we have a w, x, and w and x. So we are going to use w, x right there. Okay, so the shortcut says, I'll do it in red, you can multiply every single fraction by wx. Right, you put it up in the numerator, x. Hope that's kind of clear. You can do all of that. If you choose the right thing to multiply by, you should be able to cancel out. I'll do it in blue. So see that w crosses out and leaves you 3x And this one, the x cancels. Leaves you 5w. Everybody good with that? And then on the bottom, same thing. Those w's cancel. And then here the x's cancel. And there's my answer. There's nothing else you can do for that to simplify. So that was a quick one-step thing if you're using the shortcut. You don't have to work it this way though. You can take it a few more steps and get the right answer. Okay, let's keep going. This is long, but in a normal semester we would stop there and have test 1, but since we're combining a little bit into test 2, we're going to go ahead and cover this first section, which is lines. Okay, so this is included on test 1 for this class. Okay, talking about lines. Find the slope containing the pair of points. Okay, the slope. Remember, the slope of a line is defined to be the change in y over the change in x. Hopefully you remember a little bit of this from when you learned it in high school. Most people in the past say, I really remember this. It's not too bad. Okay, so you have your points. You're just going to subtract your y's. 5 minus 1. Just make sure whichever one you start with, you start the same for both of them. You just have to do the same order. So change in y's, -5 minus 1, and then over change in x's, -4 minus -12. Alright, so just be careful with this. That means plus. So what do we get? -6. -4 plus 12. Is that 8? -6, 8. Simplifying, we can take out a 2. -3/4. My slope is -3/4. Sorry, that's messy. Alright, so being able to find the slope. So expect you could see one like this where they just ask you to find the slope, or they may take you, the very last one we're going to do in this, where they ask you to find the equation of a line, but you first have to find the slope. Okay? I will say about this also, depending on this, look, we just got a regular slope, -3/4. Please remember that for other examples, if you happen to get like, let's see, 6/1 and 6/2, and you wanted to find the slope on this, you would do what? The change in y's, 2 minus 1. The x is 6 minus 6. That gives you 1 over 0. Okay, so remember this. 1 over 0 makes no sense. This is an undefined slope. When you have 0 in the denominator, undefined. Does that make sense? This means that this is a vertical line. Okay? The other one you could see is if you had like 5 and 6, 5. Something like this. Just another example. If you want to find the slope, subtract these, you get 5 minus 5, 6 minus 7. You get 0 over -1. Okay, so this is different. 0 in the numerator is 0. Makes sense. So you can either get a regular number like the top one where we got -3/4, or you could get undefined. Once again, this means it's a vertical line. It's important to know. And if you get 0, this is a horizontal line. So when we talk about lines, we talk about slanted lines, horizontal, and vertical in this section. Okay? So if I ask you for the slope, expect to see any of these 3. Okay? Let's see. Let's look at determine the x-intercept and y-intercept. Okay, x-intercept and y-intercept, very simple. To find the x-intercept, and we will do this later in following sections. To find the x-intercept, this is how you find it. You let the opposite one be 0, right? So if you're looking for x-intercept, let y equal 0. Solve for x. Right, so let the opposite one be 0. Let's take our equation. Let's see, we've got 2x, and y is 0. And you solve 4 times 0 is 0, so you have 2x minus equals -8 What do we get? X equals -4. Okay, so my x-intercept is x equals -4. We're going to ask you to write it as an ordered pair. That's the x-intercept. -4, 0. The y-intercept is just the opposite, but same thing. So if you're looking for y-intercept, let the opposite. So if y-intercept, let x equal 0, right? Solve for y. Same step, it's just the opposite one. So let x be 0. Take your original equation that's given to you. So x is 0. Right? So we get 0. Little basic equation to solve. Y equals 2. You good with that? So the y-intercept would be 0, 2. That's how you find x and y-intercept. Okay, so for lines, notice this line from the beginning, right, has an x and a y in it. If you have an x and a y in it in the problem, that means you're going to have an x-intercept and a y-intercept. All right? If you're missing one of them, if your line only has an x in it, you're only going to have an x-intercept. If it has a y in it, you're only going to have a y. And I think next, we're down to the very end. Here's examples. Determine, I combined two problems. These on the review were split up into two different problems, but I'm just going to take these examples and answer both questions. So, notice these lines. The first one, 3x equals 9. There's no y in it. Okay, there's not an x and a y. So, if you have an x and a y, that's a slanted line. If you have just an x, that's a vertical line. If you have just a y, that's a horizontal line. Okay? So, this is a little memory peg that's helpful. You don't have to know this, but it is helpful. Hoy, okay, and Vux. All right. I didn't mean to write that in red, but we'll do it. Okay, so Hoy, we've got, if you have a horizontal line, right, that means 0 is your slope. And a horizontal line, the equation is in the form of y equals some number. So a horizontal line is in the form of y. The Vux is, of course, a vertical line. Okay, the slope, the second one is slope. The slope is undefined, so a vertical line is undefined. And it's in the form of x equals number. This to me is very helpful because I do know that it's either vertical or horizontal if you don't have both x and y, but sometimes I get mixed up on which one's which, and this helps me. So, let's look at this these two examples. The first one, 3x equals 9. Okay, the question said, determine the x and y intercepts of the linear equation. If they exist, write the intercepts as ordered pairs. And then second, determine the slope. Okay, let's first find the x-intercepts. Like I was saying, there's only an x in there, right? There's no y. So there's only an x-intercept, which means the y-intercept would be absent. Doesn't exist. Okay? So if you wanted to find the x-intercept, right? Remember, you let y equal 0. Okay, so plug 0 in for y. Well, there's no y to plug it into. You want to solve for x. You do. You solve it, divide by 3, x equals 3. Makes sense? Your x-intercept is 3, 0. Right? Your y-intercept is absent. I think that's how they ask it. They give you, you can choose absent. Okay, there is no y-intercept. Make sense? Okay, so looking at that one real quick before we do our next example. 3x equals 9. Look over here at the Hoy and the Vux. So notice there's only an x. So look at this vertical one right here, Vux. So when it's in the form of x equals a number, which is what we have, right? You could rewrite this example as x equals 3. That means this is a vertical line, okay? And the slope of a vertical line is undefined. So when we asked you to find the slope, you would say the slope is undefined. right? And once again, the way I got that is I looked at it and thought, well, there's only an x. So I could write this as x equals 3. And from my memory peg, VUX, when it's in the form of x equals a number, right here, x equals a number, that means it is a vertical line, and the slope is undefined. Okay, I hope that helps. Let's do this other one real quick. Another example, 5y equals 90. Okay, the question was find the x and y intercepts first. So looking at that one, hopefully you can tell there's only a y. So that means there's only a y-intercept. Right? The x-intercept is absent. So I'm going to do x-intercept absent. I think that's the way they word it in Pearson. You can say it doesn't exist or it's absent. Y-intercept, remember, let x equal 0, right? Solve for y. Okay, let x equal 0. There is no x to plug in, so you have 5y equals 90. Right, and so if you were to solve that, divide that, what is that? Y equals, is that 18, I think? 18. Yeah, y equals 18. So my answer would be, what, 0, 18? It's my y-intercept. And the second thing that asked for is determine the slope. Well, remember over here, right here, oops, when it's the hoy part, when it's y equals, which it is, that means the slope is 0. So slope equals 0. Okay, I'm definitely scribbling all over the page on this, but I hope that makes sense. I combined a couple of problems into these. Okay, one more to go. I know this isn't long, but one more. Find the equation of the line passing through the points. Okay, whenever I ask you to find the equation right here, we use the point slope formula, which means you have to have a point, right? And you have to have the slope. Once you have those, the point slope formula, sorry, this is messy. The point slope formula is this. Y minus y1. And you can plug it in. It's a formula. If you plug that in, that's the equation of a line. Okay, so we have to have a point. Well, we have 2 points. We can pick either one. It doesn't matter. Okay, and now we have to have a slope. Well, we don't know the slope. So we have to first, let's find the slope. Right? We're changing y over changing x. Let's do that. Okay, we have y. So we have what? 3 minus 1. And then negative 1. Negative 1 minus 1. So what we get, we got 2 over negative 2, which is negative 1. So my slope is negative 1. Okay? Slope is negative 1, and let's pick a point. Our point I'm going to choose, doesn't matter, but I'm going to choose 1, 1. Right? If you want to try the other one, you should get the same answer. All right, so let's plug it in right up here. Point slope formula. The y1 and the x1 comes from the point, so y minus 1. Slope was negative 1. This one's just kind of weird. It ended up having a bunch of 1s in it, but that doesn't always happen. So here's my formula, but to write our answer, they want you to write it in slope-intercept form, which is basically in the form y equals mx plus b. So we actually have the equation here, but we just need to rewrite it. So we want to solve it for y. This will finish off this way, negative 1x. And then finally, let's add 1 to both sides. We get y equals, and there we go. And there's my line. Pearson might say it's not simplified if you actually write the -1 there, but I certainly would give you credit for that. I could go back and give you credit. This is your equation. All right, okay, that was really long. I know it's been pretty long, this whole video is, but it does take you through the review. Okay, I hope this helped, and good luck on the test.